This video talks about how carbon fixation takes place in the stroma. In the stroma, there is a chemical that is responsible for accepting carbon dioxide. It has 5 carbon in its structure. Carbon dioxide and the 5C compound will combine. When they combine, it will turn into a 6C compound. However, this is a very unstable compound, so shortly afterwards, it's going to turn into 3C compound that has 3 carbons in its structure. The 3C compound will then turn into triose phosphate, which is very important because the triose phosphate is the one that can turn into glucose. Now, in order for 3C to turn into triose phosphate, you need 2 things. First of all, you need to have H atoms. Secondly, energy is needed to drive the process. Therefore, in order to have H, any NADPH that was made from the photochemical reactions will give up its H to become NADP again. The H will feed the 3C to become triose phosphate. Also, ATP will turn into ADP and P again to release its energy. This energy can drive the process of 3C becoming triose phosphate. Now, not all triose phosphate becomes glucose. Some triose phosphate will eventually turn back into the 5C compound. The 5C compound has to be regenerated because if it doesn't regenerate, then you can't take in more CO2 from air. So the 5C compound is regenerated to take in more carbon dioxide so that the cycle can continue. But for triose phosphate to become a 5C compound, you also need to have energy. So in order to power this process, some ATP again will turn into ADP, releasing its energy to drive the process. By the way, this ATP also comes from photochemical reactions. Now, what happens to the NADP, ADP, as well as P after carbon fixation?